So welcome back. Assalamu alaikum guys. Welcome to my YouTube channel Chromatography. I hope that you are doing good well. So we are here with another new topic of chromatography, which is the classification of chromatography. So I hope that you already watched my previous video. If you watched it, then go and like and subscribe my channel. And further, our today's topic is that the classification of chromatography, and its classification is based on according to the principle first one, which includes adsorption, partition, further ion exchange, size exclusion, electrophoresis, and chirality. Second one is according to the polarity phases, which includes normal phase and reverse phase. And third one includes the according to the mobile phase, including liquid chromatography, which includes paper chromatography, liquid solid chromatography, which includes column, TLC, HPTLC, etc., gas solid chromatography, and gas liquid chromatography. And another one is according to the geometry, which includes planar and column chromatography. Further, we have theory of chromatography. There are two theories to explain the chromatography, which are plate theory and rate theory. So let's start with the plate theory. It was explained by the Martin and Saint in 1941. The theory assumes that the column is divided into a number of zones or the plates called theoretical plates. Chromatographic column of 1 centimeter is divided into n small sections of equal length and height. Each small section is called theoretical plate because no such section exists in reality. The length or the height of each theoretical plate is such that when solute molecules travel that distance, a new equilibrium is established. The solute molecules constantly get exchanged between the stationary phase and the mobile phase when they travel across the column. The solute molecules travel in the forward direction along with the mobile phase only when they are in the mobile phase. They remain stagnant and when they are in the stationary phase. The more the number of theoretical plates associated with the given length of the chromatographic column, more will be the such equilibria, and solute molecules will have less time and chances to spread across the stationary phase. Whereas HETP is equal to L divided by N. HETP is the height equivalent to the theoretical plate, L is the length of column or plate, or N is the number of theoretical plates. N is equal to 16 VR divided by W whole square square. H is equal to HP, HETP is equal to LN is equal to L over 16. The value of N is 16. So VR is the retention volume and W is the base of the base. Now we are going to discuss models of plate therapy, which are the discrete flow model and the continuous flow model. In the discrete flow model, assumption in this model are all the mobile phase moves from one segment to the next segment, and the multiple sample molecules are always in the equilibrium with the mobile in the stationary phase. Continuous flow model includes that the mobile and the stationary phase remain in equilibrium throughout the separation, and mobile phase flows from one segment to the next segment at a constant rate. And third one is the perfect mixing take place in all the segments. So our second and the last theory is the rate theory. It was discovered by the Van Demter. It describes the effect of an elution band as well as its time of elution. Van Demter equation describes the relation of the height of a theoretical plate H or HETP and the average linear velocity of the mobile phase. Rate theory gives more realistic description of the processes that work inside a column, takes account of the time taken for the solute to equilibrate between the stationary and the mobile phase, and its equation is HETP is equal to A plus B over nu not plus C nu, where A is the eddy diffusion, B is the longitudinal diffusion, C is the mass transfer, and nu is the flow rate of mobile phase. Eddy diffusion, A terms refers to the band broadening caused by the dispersion effect. Eddy diffusion, in this case, the spaces along the column are not uniform. When a sample migrates down the column, each molecule sees different path and each path is of a different length. Some molecules take a longer path and other ones take shorter path. There are also variations in the velocities of the mobile phase. This one is a picture. Further, we have the longitudinal diffusion, and it measures the ratio at which substances move randomly from a region of higher concentration to the region of lower concentration. And the concentration of analyte is less at the edges of the band than at the center. Its equation is also below, and diagram is below. And plot plot plate height versus average linear velocity of the mobile phase. Such plot is of considerable use in determining the optimum mobile phase flow rate. This one is the flow rate versus height of the plate graph. You can see clearly. I hope that you clearly understand the classification of the chromatography. If you like, if you understand it, then go and like my video, subscribe my channel, and wait for another interesting topic of the chromatography. Till Allah Hafiz.